Evidence to numerical integration. Table of the contents. Introduction. Some represent Gauss method, formulas and conclusion. Introduction. For this project, the country of Mauritania was chosen as the case of study. The main objective was to mark different points within a specific area using geographic coordinates, considering the both latitude, longitude of each point. With that data, we apply numerical integration methods to calculate the total area covered. This approach allows of the estimate of the Terran currency ever when dealing with real-world data. That doesn't follow perfect mathematical functions. The goal was better to understand the size and the shape that this select region and how it changed in terms of elevation and the location. The analysis in this area, I analyzed with the chosen country. I mark a total of 222 points, carefully select over the main landforms, elevations, and geographical features. These points were precisely defined of the currency represent the variations in the landscape, which allow for the more effective application of the numerical integration methods. Use the project I choose because it's the country that is of to taking out. It is the rich cultural, historical, and natural background. I found it interest to highlight the territory is overlooked. The speed is the geographic cultural diversity. Working with this country allow me explore is the land people. They identify it is great deep, which add a value of this analysis. Okay, we explain the Gauss method, also known as Gaussian elimination, is the mathematic technique used to solve problems of linear equations. It transforms a system into a simple for using a sequence of algebraic steps that make easier to find the values that they unknown variables. This method is based on representing of the equations as the matrix and then using row operations to reduce that matrix to an upper triangular of each form. One of the systems is that form. The solutions can be from callbacks, the substitution. Gaussian elimination is widely used in mathematics, engineers, physics, economics, and other things. Is that specific useful with dealing with multiple equations that unknowns, as it provides the systematic way to solve them efficiently. The method can also be used to find the inverse of the matrix of the rank of the matrix. Made is fundamental to look linear algebra. The first step is write the system as the argument matrix. Start by expressing the system of linear equations as the matrix, placing the constants from the right side of the equation in the last column. Make the learning coefficient of the first row a 1. Is this not already? You can do this by dividing the entire row by the learning coefficient. The 3. Use the row operations to create zeros below the leading one of the first column. Subtract substitute multiplies of the first row of the rows below. It's to eliminate the values under the first pivot. 4. Move the next row and the column and repeat. Make the next pivot a 1 that is necessary or no, and use it to eliminate the values below it. Repeat this process for each row to create the upper triangular matrix of the area or whatever. 5. One of the matrices is the row echelon form. Solve using back substitution. Start to the bottom row and then solve the variable and substitute of rows to find the others. To make the coordinates to UTM, they only have 4 steps. 1. Identify the latitude and longitude of the point in decimal degrees. 2. Determine the UTM sum base of the longitude. Each sum is the 6th weight. 3. Apply the conversion to UTM. Use line tools, GS software, or any formula. 4. Obtain the results in meters, easting and northing, and the UTM sum. After converting the geographic coordinates to UTM, we use those coordinates to calculate the area of the country in the square meters. To do this, we follow a mathematical procedure using the planar coordinates method. First, we multiply the UTM east coordinate of each point by the UTM north coordinates of the next point. The total sum was the product's scalar letter A. Then we did the opposite. We multiply the UTM north coordinates of each point by the UTM east coordinate of the next point, and the total of those products is scalar letter B. You can make this to all the coordinates. Once we had the sum of A and B, we subtract B from A and divided the result by 2. This final value is the approximate area in the square meters of the polygon that represent the country. To convert this area into square kilometers, we simply divide the area in the square meters by 1 million. Since the square kilometer is equal to 1 million square meters. Next, we compare the calculated area with the actual area of the country, which found using a source in the internet. This allows us to calculate the margin error using the following formula. Subtract the real area from the calculated area, then divide the real area and then multiply by 100. The result gives the error expressed as the percentage. It can be observed that the margin error was low, only 1.519%. It indicates that the area we obtained using UTM coordinates was very close to the actual value. Therefore, we can conclude that the polygon drawing, the conversions, and the calculation procedure was accurate. The shape generated closely reverse than the real shape of the country, which validates the effectiveness of the method used. The final conclusion. This project we successfully estimate the area of the country using UTM coordinates and the numerical integration method. The conversion from geographic continents to UTM along with the application of mathematical processes such as the planar coordinates area formula allowed the obtained the result was very close, which demonstrates that the methodology used that both appropriate and relevant. Additionally, the analysis made it possible to graphic represent the country shape with accuracy, confirming the effectiveness of the process.